Welcome to Techbrothersit. Aamir. In this video, we are going to learn about a local checkpoint in PySpark. Local checkpoint in PySpark is used to the checkpoint our data frame to the memory. So locally on the executor, that's what happened. So when we apply the local checkpoint, it's going to checkpoint our data frame to the memory. It helps in breaking the lineage of a data frame to improve performance or avoid stack overflow errors. Now, unlike a checkpoint where we need the directory, here in the local checkpoint does not require any checkpoint to directory configuration. But since it's stored in the memory, data can be lost on executor failure. So now let me take you to a little more detail and try to understand this whole concept. So what we want to first of all understand what is lineage. In Spark, when you perform transformations on data frames such as filtering, mapping, joining, etc., Spark does not immediately execute these operations. Instead, it builds a directed acyclic graph, we call it DAG, of these transformations. The DAG represents the lineage of the data frame, how it was derived from its source data. So those are the steps it build, like okay, when you keep applying those transformations, it build all the steps how exactly the data is derived from the source. So you got the definition of that one. Now Spark uses this lineage information for various purposes, including lazy execution, only executing the necessary operations when an action like show, write, count is called. Fault tolerance, it also if a node in the cluster fails, Spark can recompute the lost data by replaying the transformations in the lineage. So as you see that it's a graph, so it's a list of all those transformations what has been applied. So in case of failure, it will reapply those and recompute the data frame. Now that's good. We know that these two things helps. And the optimization, Spark can optimize the execution plan based on the entire lineage. So once it has all the lineage, then it can take a look on that one and perform some optimization. What does breaking the lineage mean? When you explicitly break the lineage of a data frame, you are essentially telling the Spark to materialize the current state of a data frame and then start a new lineage from that materialized state. This is typically achieved by operations such as a checkpoint or local checkpoint. So why is breaking the lineage is important? So that we need to understand. Now, okay, very first thing is it is a performance improvement. Avoiding recomputation in long chain of the transformation, if you need to access the immediate data frame multiple times, for example, in iterative algorithms, Spark might recompute the entire lineage each time. Breaking the lineage by check-in point materialize the intermediate result, so subsequent access are much faster as Spark can read from the checkpoint instead of the recomputing. Now, reducing a DAG complexity, a very long lineage can lead to a complex DAG, which might be harder for Spark to optimize. Breaking the lineage simplifies the DAG, avoiding stack overflow errors. In extremely long transformation chain, the DAG can become very deep. This might lead to a stack overflow errors in the Spark's internal processing. Checkpointing breaks this long chain into smaller, more manageable parts, and then finally we have a fault tolerance for checkpoints. While local checkpoint stores data in memory and is susceptible to executor failure, the regular checkpoint writes the data frame to the reliable storage system, such as HDFS or S3 buckets. This provides a more robust way to recover from the failure, as Spark can reload the data from the checkpoint instead of the recomputing the entire lineage from the beginning. So these are more detail if you're looking into that, but if you're not looking into that, you can simply, if you understand the definition and all that, we can start from here. Now here, if you see, this is a step that we need in the checkpoint, so we don't really need to have a directory here. I'm going to go ahead and just comment this out. Now we have data, sample data here, and I'm creating with the name, profession, and then age. And here is my data frame df. So I created this data frame, create data frame, use this above data and use the column definition from there. Now once this data frame is created, I'm applying some transformation. So here I'm doing with the column, so adding a new column, and then what I'm doing, age plus 10. So we are adding 10 to the age column, and this is called the df transformed. After adding the column in the df transformed, we can apply the checkpoint. So how you do that? This is a df underscore checkpoint, and then you say this is the data frame that we use above, and then dot local checkpoint. This breaks the lineage and cache the data frame in memory. So now whenever we want to use it, we will be using this data frame, and it's not going to do all these transformations every time we use this data frame. And here we are showing the results from this data frame. And finally, if you want to perform further transformations on this data frame, you can also do that. So here I said df filtered and the df checkpoint. So this is a data frame that we created as a part of a local checkpoint. We are filtering column where age is greater than 40, and you can see that the results from the df filter.show. So I'm going to go ahead and execute and let's start and run attach. So here is our data frame output, and this was from this output right here. So this data frame you see right there, df transformed. So right there we have it before even we applied the local checkpoint. So then we applied the checkpoint and we got this df checkpoint data frame. So here it is before even we applied the local checkpoint, and you can see the results right there. And then we filtered the rows where age is greater than 40. So you can see that it is giving us the results, and this is coming from after we applied the checkpoint on the this data frame. So we applied the checkpoint, then we saved the results into df checkpoint, and then we kept using wherever we need to use it. And finally we were filtering the records from this data frame and printing it out. So I thank you very much for watching this video. Please subscribe my channel, and I will see you guys in the next video.